Alright, today's class we're going to cover how to tell if there has been a reaction. And we've got an example from our homework questions. It's number 4 on the handout. In that handout we have potassium hydroxide reacting with phosphoric acid. So I wrote the molecular equation first. That's where you write everything with all the components still together. And what you do is you switch potassium with phosphate, and the hydrogen goes with the hydroxide, so you get 3 water molecules forming and potassium phosphate as byproducts. In the Ionic equation, we just show everything dissociated, so with aqueous potassium, aqueous hydroxide, aqueous proton, and phosphate anion. And then we'll see that the water forms and that you still have the potassium and the phosphate sitting in solution. That's why we cross them out, because they're spectators, which gives us the net ionic equation. When we cross out the spectators, all that's left is the net reaction. Let me just erase that. So this is the net ionic equation. 3 protons combined with 3 hydroxide ions to form 3 water molecules. So there's definitely a reaction there. Whenever some product forms, either liquid or solid, then you know that you've had a reaction. Before we continue, we should know the difference between an electrolyte and a non-electrolyte. A non-electrolyte is a substance that can dissolve in water but does not produce ions, and as a result does not conduct electricity. For electricity to be conducted in water, there has to be an ion to carry the electrons from ion to ion. Now, pure water doesn't have any ions, or it has very, very few, so it doesn't conduct electricity under normal conditions. Now, an example of an electrolyte is sodium chloride. Sodium chloride will dissolve in water to form sodium cations and chloride anions. Therefore, it is an electrolyte, and this is how we portray it. You show sodium chloride solid, add water, and you get sodium cations aqueous and chloride anions aqueous. Aqueous symbolizing that it's dissolved in water. Glucose will dissolve in water as well, but glucose doesn't produce any ions. So a solution of glucose does not conduct electricity. This is how you would portray the dissolution of glucose. Glucose is a solid, you put it in water, and that dissolves into the water, so that's how you symbolize it. You put AQ to show that it's dissolved in the water. There are 2 types of electrolytes: strong electrolytes and weak electrolytes. Strong electrolytes form many ions when you dissolve them in water, whereas weak electrolytes form few. An example of a strong electrolyte would be a strong acid or a strong base, whereas a weak electrolyte might be something like acetic acid, something that only produces few ions in solution. If you look in your textbooks, there's an illustration of how a strong electrolyte conducts electricity very well, because when they dip the light bulb with the 2 electrodes in it into the solution, the light bulb burns brightly, whereas with the weak electrolyte it only burns very dimly because very little electricity is being conducted. It is important to know the solubility rules when you try to formulate whether there's been a reaction or not. So it's important to memorize at least which things are soluble. All nitrates and acetates are soluble. Halides are soluble except salts of silver, the mercurous cation, and the plumbous cation. So for example, plumbous chloride is not soluble. Sulfates are soluble except for the salts of strontium, barium, the mercurous cation, and the plumbous cation. So for example, mercurous sulfate is not soluble according to that rule. And also, all group 1 cations and ammonium salts are soluble. Solubility rules help predict if a reaction will occur. If solubility rules predict the formation of an insoluble substance, then it is considered a reaction. If no insoluble products form, then we say there's no reaction. An example of no reaction would be where you mix potassium nitrate with sodium chloride. The 2 products that should form are potassium chloride and sodium nitrate. Both of these products are soluble. Nitrates are soluble and chlorides are soluble, definitely if they're group 1 chlorides. So no insoluble precipitates form, therefore no reaction. Nothing comes out. If you mix a solution of potassium nitrate and a solution of sodium chloride, there'll be 2 clear solutions. After you mix them, they'll still be clear because nothing will have formed. In the second example, we have iron sulfate combining with lithium hydroxide. The two potential products are lithium sulfate and iron hydroxide. If you look at the solubility rules for sulfate, you'll see that all sulfates are soluble except for these ones, for these group 2 metals and some other heavy metals. But lithium is a group 1 metal, so this sulfate is soluble. So nothing forms because of this, but on the other hand, hydroxides are not soluble, with few exceptions. And iron hydroxide is not soluble. So this will form a solid. This is a reaction because one of the possible products is actually insoluble in water. We did then number 5, an example from homework, where we showed the electric equation, the ionic equation, and the net ionic equation. As it turns out, both the ionic equation and the net ionic equation in this question are the same. Magnesium hydroxide mixes with hydrosulfuric acid to get a magnesium sulfate and water. Both of these are products that form in this reaction. So this is definitely a reaction. In this question, ionic and net ionic equations are identical because both products form. There are no spectators in that question. So some rules we can use to help predict whether exchange reactions are actually taking place. First, we exchange the partners, as it were, like we do here. The barium goes with the hydroxide, and the potassium goes with the nitrate. Next, we balance the equation to make sure everything is in the same amount. So there's 1 barium here, 1 barium there, 2 nitrates here, 2 nitrates there, 2 potassium, 2 potassium, 2 hydroxides, 2 hydroxides. So this is balanced. And then the third thing is we check to see if one of the products is insoluble. If yes, then there is a reaction. If no, then no reaction. In this particular case, barium hydroxide is soluble, and potassium nitrate is soluble. So this particular reaction is predicted not to produce any product. No solid, therefore no reaction.